All right, guys, April 30th again. This is the second part, so this is section 10.5. A couple more theorems that we need to apply here. So we use the Pythagorean theorem to find side lengths of right triangles, so obviously we're going to use the Pythagorean theorem here again. Use properties of tangents, and we'll learn what that is here in a little bit. And solve problems involving polygons that are put around certain items, or circles that are put around polygons. So a tangent is a line that intersects a circle in one place. Okay, so it just touches it in one place. The point of tangency is that point that the tangent touches the circle. A common tangent is if you have more than one circle and you can draw a tangent that will touch each of those circles in one place. And that's what we're going to look at here. So this particular circle, can we draw a common tangent? Is there a tangent that would be, a line that would be tangent to both circles at the same time? And I would argue there is not in this case. No matter what I do with this inside one, it will touch the outside one in two places. So I don't think there are any common tangents here. Whereas when I look at this one, there are definitely some common tangents. I can draw a tangent across the top here that will touch both circles in one spot, across the bottom. Okay, and as you draw them in there, I think you can see that there's definitely two common tangents in that circle. Okay, what do you guys think? So this particular circle, how many common tangents do you have? Okay, so we've got some across the outside here. And then kind of going diagonally across the inside. We'll see if they draw them for you here. Looks to me like there's 4 of them. Okay, and so that's really all it is. A line that will touch both circles in one place. Okay, how about this one? Okay, I think you got the one's on the outside here, but I think you can draw one right up the middle here because it looks like those two circles are tangent themselves. Okay, and so there you go. There's your 3 common tangents. All right. A line is tangent to a circle if and only if it's perpendicular to a radius at that point of tangency. So that's how I'm going to know if that line is in fact tangent. I'm going to check to see if I've got a right angle there. Okay? And so determine whether that is tangent to the circle. Well, the only way to know that for certain is to know if I have a right angle. Well, if I go back to chapter 8, Pythagorean theorem, use my right triangle stuff. If a squared plus b squared equals c squared, well, it means I have a right triangle. And so I'm going to test that out here. Okay? 20 squared plus 21 squared, I get 841 for both. That is a right triangle, so that means that LM is tangent based upon the theorem we just learned. All right, so you give one a shot here. Same scenario. I'm going to check 14 squared plus 16 squared. And I'm going to compare it to 21 squared. Okay, so for me, 14 squared plus 16 squared, I get 452 on the left side. 21 squared, I get 441 on the right side. Those are not equal, so YZ is not tangent at that point. Okay, even though it looks like it is, we need to do the math and test it. That would be a question that would definitely show up on the test. Okay? How about here? Same thing, it tells me that this is tangent, so I gotta find x. I know I can apply the Pythagorean theorem, but this is gonna require a little bit more algebra. That side's x, that side's 24. DE is x plus 16. So when I use the Pythagorean theorem here, that hypotenuse is x plus 16. Now what you have to remember, the left side's easy, but when you square a binomial like this, you're going to get x squared plus what you get when you multiply those together doubled. So plus 32x plus 16 squared, okay, or 256. You've got to remember that middle term. A lot of kids forget it. Well, now I can subtract an x squared from both sides, and I'm going to lose the x squared, which is handy. Okay? And then at the same time, they subtracted 256. So I divide by 32, and I get 10. And that's all they're asking me to do is find the value of x. Okay? All right, so you get one a shot here. See what you come up with. We'll work it out together. Okay, so my hypotenuse is this ij. So I'm going to be able to say that x squared plus 16 squared equals x plus 8 quantity squared, okay? Well, the left side, that's not too bad. 16 squared, what did we say in the previous one, was 256? Yep. here I'm gonna get x squared. 8 times x is 8x, doubled is 16x, and 8 squared is 64. Okay, so I gotta remember that. I'm gonna subtract x squared from both sides. That's gonna eliminate that. And then I'm gonna take 256, and I'm gonna subtract the 64 that I have on the right side. And I'm gonna get 192 equals 16x. So then I have to divide by 16, and I get x equals 12, okay? So that's what your algebra is gonna look like for a problem like that. Okay, if two segments from the same exterior point, so they're both coming from B, are tangent to the circle, so BA and BC are both tangent, then those line segments are congruent. BA and BC must be congruent. So the algebra here becomes pretty straightforward. They're definitely tangent from the same exterior point. I set those expressions equal to each other, and I solve for x. Move the 3x over, move the 3 over. I get x equals 5. Pretty straightforward. I don't think you guys are going to have much trouble with that. Okay, so why don't you give it a shot really quick, see what you come up with. Again, these are both tangent from the same external point. So I'm going to say that 5x plus 4 must equal 8x minus 17. Subtract 5x, I get 3x. Add 17, I get 21. Divide by 3, x has got to be 7, okay? These ones should be fine for you guys. Okay, this one, the round cookies are marketed in a triangular package to pique the customer's interest. If QRS is circumscribed about circle T, find the perimeter. Okay, well here's the thing, you guys. If that's 2, then both of these line segments are 2 here, because if they are tangent from the same external point, then they're congruent. So if this is 10, this is 10. If that whole thing is 8, 8 minus 2 is 6, that makes this 6 and this 6. And so my perimeter is going to be 10 plus 10 plus 2 plus 2 plus 6 plus 6. Okay, and we're going to see that as they work out the math here in a second. 10 plus 10, 2 plus 2, 6 plus 6. They use the whole side of 8 instead of the 2 and the 2. Okay, but let's see what we come up with here. Similar situation. If that's 6, this is 6. If that's 16 all the way across, that makes this 10, and that 10, and that 12. So 12 and 12 is 24. 10 and 10 is 20, so 24 and 20 is 44. Plus 12 is 56. That's how I would tackle that, you guys. All right, so page 736, 9 to 27 the odds. Give it a shot. If you have questions, please ask me.